My name is Evan Booth. I hail from America. I'm an engineer. I work for money, so that I can pay for goods and services, of course. I like the mountains over the beach, fall definitely over spring and summer. And guys, this thing, it's not even, don't get it twisted, okay? All right, this is the best friend vetting mechanism ever. This talk is Jittery MacGyver. We're going to be talking a lot about finding potential. Another word that was invented kind of in the late 80s, early 90s for finding potential is MacGyvering. To MacGyver something is to find an unconventional solution to something using, weird materials. Anyone familiar with MacGyver in here? A lot of you, great. So right, MacGyvering, this is MacGyver here. It's like 100% American because he's holding a missile, right? I'd like to think that we steal a lot from British television, of course. If there was a British version of MacGyver, it'd be called like Sir Chappie or something, and then, of course, it would be played by Sir Ian McKellen, and he would have a mullet, I think. And instead of defeating bad guys with like stuff and he makes out of things, he would just like sit down and then talk sense to them, like in his TARDIS, of course. So, by the way, if I ever tell you that I need to go leave for a bit and work on my talk, like the chances are good that I'm up in my room like photoshopping a mullet onto Sir Ian McKellen. So, just so you know. So yeah, finding potential. Let's look at some examples throughout history, right? So one that I really like is George Washington Carver. You guys are probably familiar with this guy. He looked at a peanut and saw a tremendous amount of potential in that, right? So he grew up surrounded by nature, completely inundated with nature, loved it, and became a botanist, became an educator, and of course, he's most famously known for his work on this little peanut. He saw it and he said, you know what, that could be a lot of stuff, and he was certainly right. He made a whole lot of stuff out of the peanut, right? But this is kind of his life, and like in 1896, he assumed the role of director of agriculture at Tuskegee University. And the university didn't actually tell him before he arrived that, oh, we didn't have enough money to buy you a lab, so no equipment. So he got there and he's like, okay. So he literally took his students to like trash heaps and junkyards and stuff, and they found all the stuff necessary to build out like a proper agricultural lab. So this is definitely a great example of MacGyvering, right? And this guy was awesome. So he made the Jessup agricultural wagon. This thing is like a mobile classroom. And he was passionate about agriculture, and he wanted to help poor one-horse farmers to be able to be profitable. So he would go around and teach them how to do things like crop rotation, and how to be resourceful, how to find potential, right? Another great example comes from Cuba in the 90s. And because of the trade relations at the time and the fall of the Soviet Union or Republic, the economy in Cuba just went completely to crap, right? So basically, the government at the time, they knew that this was going to be a really difficult time for everyone, and this was going to take a while to sort of fix. And so they put out two publications. One was The Book for the Family, and the other was With Our Own Efforts. And these things are basically like giant, 300-page compilations of like do-it-yourself articles and recipes and like popular mechanics, like how-to guides and all this stuff, and like just basically how to get by on the stuff that you just happen to have around you at the time, because like most people worked for the government. You don't get any money, basically. You can't really buy anything. There's no trade. So you have what you have, and you have to make do with with what you have. So these guides are really interesting. I found a version online, like they're jam-packed full of illustrations, like this one, which pays an actual like uncomfortable amount of attention to like the nipular region for reasons I don't know. This is like early do-it-yourself chiropractic at home, maybe. If you like an AK-47, you'll love one on a stick. Let's do that thing. This is probably my favorite. This is the Desplasmatizador. So you basically take settled Italian dressing, you attach that to a jar full of like hopes and dreams, and then you attach that via wire to like I don't know, this is like a yawn from a tired hippo or something. And of course you run that into what looks like the motor from a compressor from a refrigerator. And to top all this off, you plug it directly into the wall for great justice. I don't know what that does, and I'm pretty sure that if I could speak Spanish, I still wouldn't know, but it's pretty crazy. So lots of really cool stuff came out of this time period because people just had to be resourceful to get by. So this is a padlock made from just some metal tubing and some bent wire, basically. These glasses, right, if you wear these, it's tantamount to like basically rolling a natural 20 on charisma, like everything you do all the time, right? That's like ridiculously epic. This thing is actually used for recharging hearing aid batteries and also removing your need to hear, because if you mess up, you would die a lot, right? This is hand-extruded plastic kitchenware, long before 3D printing was a thing, of course. And these metal food trays, they would reuse them to use them as antennas. Brilliant, right? And one thing I really like that came out of this period was also the Eureka washer-dryer combo. And everybody had one of these, right? And almost every one of them, the dryer would crap out. And so, like, basically, like, the frequency of this particular failure spawned like an entire underground industry, because at the time you couldn't be self-employed working on stuff like this in Cuba. And so you had a bunch of craftspeople that would work on like basically just doing modifications to broken Eureka washer dryers. So like the most common modification is they'd take them in and they would just cut it right in half, right? And they would, you know, give you back your washer, that's fine. And then the dryer part, they would just repurpose. And a lot of the times it wasn't actually the motor that was bad. And so they would use it for everything. This is a coconut shredder, right? Automated key duplicators, ridiculous stuff. Attach an outboard boat motor propeller to it. It's a fan, right? Also a great way to lose all of your fingers. So just some amazing MacGyvering happening in Cuba at this time, and it just came out, just born of necessity, right? Another great example comes from 1970. This is April 11th. NASA launched its 13th mission in the Apollo program. This is the 7th manned mission, the third of which that was destined to the moon, right? And the launch was, successful. It had a few hiccups here and there, but, they made it to space, so that's good. But just under 56 hours into the mission, it heard this back at the comms desk.
This is Houston. Say again, please. Houston, we've had a problem.
Houston, we have a problem, right? So the problem was that they flipped on a switch to cut on a steering fan for one of the, I think the hydrogen tanks to get a better, level reading on it. And unfortunately, the Teflon insulation on that wire was frayed or messed up. That caused a short, which caused a fire, which raised the temperature of oxygen tank number 2 in such that it failed catastrophically, right? This is basically an end user finding a bug in production. So make sure you do unit tests, okay? Yeah. And so they didn't die, right? Because they were able to move over from the service module where they're supposed to spend their time. All of them went over, the 3 of them went over to the lunar module, which uses a completely different life support system, because the one in the service module was completely shot, right? There was another problem. See, the lithium hydroxide filters that are used to scrub, basically scrub CO2 out of the air to make it breathable, they weren't designed to support 3 men for 4 days. They were really just designed to support 2 for about 1.5, right? So the problem is that these things are starting to clog up and they're starting to fail, and so the air is becoming more and more poisonous inside this lunar module. And they actually had spare filters, but they had this like square ones that the service module used, and the receptacle for the filters in the lunar module were round, literally the square peg in the round hole, right? And so NASA, of course, back on Earth, they were like, ha 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 ha, you have no chance to survive, make your time, right? No, they were cool. They started working on this, and they knew what the astronauts had access to. And they took all that stuff, and it was like the cardboard cover of a flight plan, and some plastic sheeting here, and like some tubing there, and they built the mailbox rig. And the mailbox rig was basically an adapter for the square filters to use them in the round receptacles, right? And they sent these plans after they tested them, sent the plans back up to the astronauts, and the astronauts were able to to build one because they're astronauts, right? And the day was saved. Now, you guys are probably familiar with this story, but my favorite part of this came after in an interview with this man named Ed Smiley. Now, he was the chief of Crew Systems Division. He was responsible for building out and testing this mailbox rig. And in an interview after, he said that when we found out we had duct tape on board, we were pretty well home free. And that is ridiculous, right? Because, like, duct tape is awesome and stuff, but think about the weight of that statement. This is like a program that the U.S. poured millions of dollars into, and countless hours of, like, our brightest minds coming up with contingency plan after contingency. Everything goes sideways, and dude's like, oh, we got duct tape? We're fine, it's fine. Like, the entire world is watching. There's 3 of America's finest, poisoning themselves by breathing in space, but we've got duct tape, so it's cool, right? So really, his title should actually be 100% certified badass, because, well, he is. So history teaches a lot about some interesting examples of resourcefulness and this MacGyvering, right? So for me, I've got a few projects that sort of fit in the same vein, and I get a lot of questions about my background. So I was actually, I spent my youth in the country, and this is a newer satellite photo. So, like, my house is here, and when I lived there, this house was not there, and none of that was there. And let's see, we didn't have a pool, definitely. And these neighbors, that was the guy that yells at his wife all the time. And down this dirt road here, that was like basically like pitchfork flavored, like certain death by rednecks. So you don't go down there. But like, truth be told, this is a fantastic place to grow up, because we sort of had free reign minus the death spots. And so, my brother, I had an older brother who's sort of cut from the same cloth, which was really, really helpful too. And we would have to, find ways to entertain ourselves. So we would play Oh God Run a lot from that thing. And then we had some toys, like who can forget the classic stick? Or good old Xbox, all of these things. So I got a sort of a taste for solving problems resourcefully and in MacGyver-esque ways really early on, and it stuck with me, right? So there's a few things that I've worked on. Who in here has a big box of cables, like in their office at home? Right? I certainly did. And I looked at mine and I was like, I don't want to do something with that because they're just going to sit here forever. So I made a universal serial bullwhip. And this is an 18 plate. It's 12 feet long from end to end. And it's primarily made of USB cables, because the spec calls for braided wire, which is nice and flexible, and it's durable that way. So the USB weighs a lot, and it's quite functional. And it is ridiculously heavy, and if you don't respect it, would absolutely tear your face off. So that's fun. So another thing I worked on, I was actually speaking at a conference in Atlanta, and drove down, from North Carolina, and the night before, and I brought with me this giant Pelican case, just jam-packed full of like stuff you'd find around the office. So like a little lightweight, Dirt Devil vacuum cleaner, all-in-one printer, paper shredder, random stuff, coffee maker, and a red swing line stapler, because Milton. And so I built Milton, right? Stayed up all night, took everything apart, trashed the hotel room, but I cleaned it up later. So I made Milton. Milton is, I don't really know how to classify it, because it's heavier and bigger than a bat and a club, and it's spiked because of these solid metal paper shredder heads that I bound together with RJ45. And so I took a bunch of straight rod pieces and metal bits from the all-in-one printer and some other things, and I basically folded that into case metal, and then topped that all off with duct tape, and built Milton. And this is just a couple Evans to scale here. And here's Milton versus a coconut. Very effective. Excellent. So here's Milton versus a cinder block. Hey, good job, Milton. So the idea, or at least the scenario I built up in my mind was, I'm at the office late, the zombie apocalypse breaks out, how am I going to get back to my car and get home. So I made Milton, right? So the next thing I want to talk about is a project I worked on a few years ago called terminal cornucopia, right? So terminal cornucopia, so I'd kind of hypothesized for a number of years that a hypothetical attacker, having passed through airport security with nothing but cash and maybe like a small, like, flight approved, travel approved multi-tool or something, could build potentially lethal weapons, just using stuff that you find in gift shops and all, right? So I set up some rules. You could only use materials that can be sourced inside the terminal after the security screening, right? You walk in with nothing but cash and maybe that travel-approved multi-tool, and then anything that you get yelled at for taking or messing with in the airport's off limits. So like the drill that I'd find laying around, defibrillators, there's a bunch of crazy stuff that I've taken pictures of here and there. So yeah, I went to a bunch of airports, and it took sort of an inventory of all the things that I could get. The things that I didn't think I'd be able to find, like on Amazon or at like a local store, I would get at the airport. Otherwise, I'd just pick it up at a shop, so I wouldn't have to spend a crazy amount of money. And this led to some really awkward purchases. Right. So here's a supercut of the various things, some of them that I was able to build kind of over the course of a year. Some really interesting weapons with stuff you buy in airports. As an aside, if you've never seen a metal travel coffee mug shoot out of the side of hard case luggage like it's made of butter, then you're probably well adjusted. But you've seen it now. Cool. All right. So that was terminal cornucopia. Of course, using those same skills, looking at things around me, working with a very limited amount of resources, and seeing what's possible, right? And the other thing I worked on was practical post-apocalyptic electronics. I wanted to think through what like the fewest number of concepts would be required for the layperson to be able to build things practically with electricity, which is a really tough and big problem to wrap your head around. So one of the practical applications of this was something I did called the shack. And with the shack is a 6.5 by 11 foot unpowered shack in Kentucky. And I spent a week there, and I brought just a whole bunch of stuff that you could find around the house with me. So actually I had a Keurig, had some yard tools, just a bunch like flashlights, just random stuff, right? Took it all with me, spent a week there, and this is actually me like walking up to the shack for the first time in like 15 years. Yep, so it's safe. Okay. Yeah, that's a giant spider, so I did what anyone would. I nuked it from low orbit. Not really, because I had to stay there for a week, so I did the next best thing. All right, yeah. So I ended up using some of that expanding foam like sealer stuff, like all of it, in the whole town of Beattyville, Kentucky. And I made basically an airtight cabin in the forest, so I wouldn't die. Yeah, so I got to work. I worked on three things, right? I wanted to work on lighting, like some sort of foundation of automation, and then security. For lighting, I just use a full water bottle, which if you put next to a light source, acts as a diffuser, which makes a nice little central light. And at night, it looks like a Nuka-Cola Quantum, which is pretty cool. Those are just LED Christmas lights, very low power, very, very nice and atmospheric, right? So I had one board that it was set aside for managing power. I ended up with two poles, one for 12 volts and then one for 5. I figured those were good breakpoints, right? Because all of your automotive stuff is typically 12-ish volts. And then, of course, USB with 5. Tons of power sources that put out 5 volts. Tons of things that consume 5 volts, right? Same goes for 12. So I set this up to to use these like hot swappable batteries for like power tools and stuff like that. Fed backwards through this particular wall wart would give me a somewhat close to 12 volts. It's good. This is just a USB adapter from a car, right? So all of this stuff is fed from a marine battery, from an ATV. And all of it kind of leads up to this control board. And here are 3 switches. This is just a basic switch to control the main light. And I built these switches with varying degrees of insanity, just to show variety, right? This one controls kind of the home automation stuff, and this is my security, right? I got 12 volts coming in here, and then 5 coming in here, and I laid it all out so you could sort of visually inspect and see what's going on. Ended up using some nice 12-volt relays that you can get out of basically anything that clicks, like your AC when it cuts on. You guys don't have like air conditioning here, do you? Never mind. Your HD TVs, they have these. Your refrigerators got them. A bunch of stuff, right? They're in everything. Actually, if you drove a car here, you probably drove like half a dozen 12-volt relays because they use relays, right? Here's a close-up of the security switch, which is fun because like when you close it, you have to actually turn the key to unlock it, right? So basically, I took a momentary switch out of a leaf blower, mounted that to the door with some nails, and that sort of allowed me to be able to toggle the light on and off, make sure that when I opened the door, I never walked into a dark space, which is crucial in Kentucky. And I even went so far as to put like a status LED on the board, just in case I didn't know if the door was open or closed in my shack, Totally useful. So for the alarm, I took a head unit out of a car, specifically the bits that feed and eject the CD. So this guy right here, this mechanism, and basically set it up to where if I power this, then this will start spooling on and start gathering the string, which is just on a nail here, and eventually tug out this little piece of plastic, which is the only thing keeping that clothespin from clamping shut. And there are 2 leads on either side, right? And those leads connect this completely separate circuit, or this bank of 9-volt batteries. So this is how that works. So basically, it's a very, very, very convoluted and interesting way to make a latching circuit, right? Or latching relay. And for an alarm, it's important because, like, if you want your alarm system to go off, you don't want someone to undo that by, undoing the action that caused the alarm to go off, or shutting the door, whatever. So basically, you power this thing on once, it's going to close the circuit that's segmented, and it's not going to reopen it, right? And of course, that 9-volt battery source there ran down to a very thin wire wrapped around the fuse of the weasel, right? So if you put a lot of power through a thin wire like that, it heats up really fast. It acts as a resistor, and that makes things interesting. So listen, you should set fireworks off in your home. That's kind of the takeaway here. Write that down, okay? Don't do that, actually. Yeah, do it. I'm not the police. I don't care. It's fine. So yeah, so then I sort of wanted to narrow my focus a bit because I felt the scope of that problem was a little too large to maybe solve in a meaningful way, and I guess in a hobbyist capacity, right? So I started looking at Keurigs, and Keurigs, I don't know if that's really much of a thing here, but it's basically like one of those single cup pod-based coffee makers, right? You guys familiar with Keurig? Cool. So yeah, they're pretty much everywhere in the States. Last year they did a survey and like nearly 1 in 3 American homes had one of these single cup coffee makers, and the leading brand is certainly Keurig. There's no lack of critical like failure-inducing issues with these things. They get tossed all the time. I thought that was interesting. And there's a really neat variety of parts inside, right? So what's inside these? You'll typically find some sort of display. Some of these displays have, some other components, maybe some buttons on as well. The newer ones, they cleaned it up a bit, and they used a four-conductor touchscreen, and basically just do all the stuff through software. So that's that. They'll have a main controller board of some sort, and they're kind of like a mullet. Actually, it's sort of like solder them out on the front, through a hole in the back. Oh yeah. But yeah, lots of interesting stuff here. Kind of the usual suspects. You find a lot of ribbon cables. Some of these have nice transformers. Some of them, they move like their power management stuff off to separate boards. You'll have like nice little breakouts, like this 4-wire like momentary switch with a couple LEDs. Nice reusable component. A variety of switches, so leaf switch, magnetic switch. They actually had the bottle cap inside to take photos for scale. That was nice. The newer ones, they implemented DRM, and they did that through a I2C RGBA sensor. So basically looking at patterns on these K-cups, right, the pods, to be able to tell if they're legit or not. And like to circumvent this, you just cut the green wire. Like, come on, guys. Could have made it like a different color, so it's not just like the movies, right? You'll find a motor of some sort. This is from a higher-end Keurig. A very nice stepper motor. Has like built-in interface for speed controller, brake, reverse, built-in Hall effect sensor, a whole bunch of crazy stuff. Very nice. The thing on the left there is a 12-volt air pump. I think it's an older prime-free water pump. The older ones had these nice 12-volt solenoids, which are pretty cool. They did away with that in the newer models. All of these will have a boiler of some sort, and these are in a variety of shapes and sizes, but they're basically metal on plastic, right? Enough tubing and stuff to choke a donkey, certainly. Lots of connectors there. And then you'll find a lot of these little metal bits, like things that you'd put in a sock if you wanted to kill someone in prison, right? And loads of plastic, so casing plastic, and plastic has sort of become more prevalent in these things as the engineering has progressed. So that is a huge, huge variety of parts. Holy crap! Where do we start, right? So just a quick disclaimer: I don't represent Keurig in any way. I haven't talked to them at all. I'm a customer. I have one. I've used it every day. It's decent coffee. It's basically just quick, which is what I need. I say what I want. All that spaghetti. Okay. So the first thing I did is I bothered my friend Dan Tendler for his thermal cam, because I wanted to see what these things look like under thermal in normal operation. So when these things operate, typically you've got water in a reservoir. That gets pumped out into the boiler, and then that boiler heats up the water to an ideal coffee temperature, which is actually user programmable in some cases. And then once it reaches that desired temperature, an air pump dumps water in, that forces the coffee out over your grounds into your coffee cup, and then you're drinking coffee, right? So obviously the first thing I wanted to do is make this fail a lot. So I started working on Warpaw, which is the worst part of waking up, which is a play on the Folgers thing slogan, which might not be a thing here. All right, cool. So yeah, I took it apart, and this isn't an exploit, right? This is just straight up sabotage, right? I wanted to sabotage this unit. I had physical access, the sky's the limit, right? So I took it apart, started looking at where the power was coming in and where it was going. So it feeds into the main board, and it goes back out into the boiler, or into the heating element that runs through the boiler. But along the way to here, which is the heating element for the boiler, it passes through a couple of sensors, right? And so these are both thermal sensors. The one on the top is just a basic thermal switch. The one on the bottom is a permanent thermal cutoff. So if it reaches a certain temperature, it literally melts like an organic pellet inside, and it releases a spring, which causes the circuit to fail permanently, right? And I wanted to bypass that. And they also, on the main board, they've got these really kind of nice pressure sensors. And like just a tube feeds in from the bottom. And I can imagine that that is probably used to monitor failures as well. So the issue is how to get the AC current coming from the wall right to the heating element. Oh yeah, wire nuts, those are a thing. So yeah, I just cut those wires and then, basically connected that heating element directly to the, to mains, right? The other issue was these three tubes coming out the top for, passing in water and air. And so I thought about that. Oh yeah, right, epoxy. I'll just epoxy those shut. So right now we've got water in a boiler, because in a Keurig there's always water in the boiler. And as soon as I plug this thing in, right, it's going to start heating up that water, and then something bad is going to happen eventually. So here we go. Oh man, that's not good, right? Let's take a look at the thermal here. Everything seems fine until, okay, all right. It just becomes Satan's butthole in like a matter of seconds there. And this continued to heat up until all the water was gone, and then it just started melting a lot. And it smelled awful and was like filling my house with smoke. I don't recommend this at home, by the way. And eventually, it started, like you can see, like it started melting, bits of the stuff on the side. So what happened, I thought, crap, one of my, epoxy, joints failed or, something like that. But no, they were all intact and it was fine. So what happened? Well, shoot, the thing got so hot, it melted the plastic on the top of the boiler, kind of slid to the side, and eventually just gave up, right? And so it released the steam on its own, which actually, that's a pretty good result from an engineering standpoint, because this is not a catastrophic failure, right? This is something that, is not going to cause bits to fly around. And, I was disappointed. I wanted it to blow up, obviously, because I'm me. But it's okay, because science, right? This is something we can learn from and move on from. So something else I built, actually, just over a weekend at a conference, is Debug, which is the delicious script, which is the delicious beverage dispensing badge of unmitigated Goran glory. Any Firefly fans in here? What are you guys doing here? Go home and watch Firefly. Oh man, or maybe later. This is a great con. So yeah, this is my badge, and essentially it's just a 12-volt solenoid, a 12-volt air pump, and I've got two switches. One cuts on the pump, one cuts on the solenoid, and so the air pumps water into the delicious beverage holder, and then as soon as you hit the other button, the solenoid opens up and allows that beverage to come out in a little teapot here. So it worked out pretty well. Hey. And when I fly with this thing, I try to leave a note all the time, because it looks like sketchy as hell, right? Oh, man. So there was that. All right, so the next build was Hedberg. And this is sort of like the first big build that I ended up recording. And Hedberg is actually not an acronym. And I wanted to work on something, because it was definitely not what I'm used to, but something that other people were working on, right? Something that other people had sort of made good progress on, in 3D printing, and something that was like people were actually doing well to solve the problem. And so I was basically just stepping in to kind of see where I could fall in terms of success on that spectrum against a well-established baseline, right? So I started making throwaway junk prototypes just to see what the materials were like, what I had to work with. And so I made a few things just to sort of test joints out, figure out how things would generally be constructed, right? And I looked at different ways to form fingers, looked at stability, looked at how much material was required for that, because you're always in short supply when you're dealing with something like this. Yeah, so I tinkered a little bit with some throwaway prototypes, and I cannot stress the importance enough of throwaway prototypes. You should absolutely be doing this. Build something you don't care about just to learn from it. It's fantastic, especially with this sort of thing, because you're going to fail a lot, So yeah, I did this for a while, and I felt like I had enough knowledge to kind of get started. So I started working on Hedberg. And what I wanted to do was use one single Keurig, and only external materials that I would use are adhesives in the actual unit. And I would be powering this with an external, like, rechargeable lithium-ion battery, right? I used basic tools like a Dremel, a heat gun, a drill, hand tools, lots of hand tools, files, stuff you might have around the house, right? Nothing too exotic or something to be like, well, I could build this if I had that, I didn't want that, so I wanted to use basic tools. Didn't have any real plans going in. I kind of had some knowledge that I rolled in from the throwaway prototypes, and it ended up taking like just south of 200 hours of hands-on time, start to finish, to build Hedberg. And I recorded all of those hours, and it was a tremendous amount of footage. But yeah, that's working time. So that's like every time I would, actually like reach into my desk to, put my hands on things, I would start recording and stop when I move away. So thinking, planning, sketching, stuff like that along the way, not on that figure. So here's a time lapse of the process start to finish. Sped up, of course. Hey, so that's Ed Berg. Here he is. Ed Berg's clicky. Awesome. So, just a couple technical things about this real quick. So it has a distributed grip strength to some degree. So basically, ideally, you would want to have an individual, control over fingers, so you could adjust things kind of as you go. A compromise for that here was when fingers, on one end meet resistance, the others will sort of pick up the slack basically, just by using that fulcrum there. Obviously, I made a neat case for it because you have to do that if you build hardware, which is super fun at the airport, by the way. What the hell is in there? It's a hand, man. Sorry. So let me talk to you one of the technical challenges that I faced when building this, and that was simply slowing down the motor. So basically, the motor that provides the torque that actually closes the hand is the primary brushless DC motor responsible for running the pump that gets the water out of the reservoir, because it's the most powerful one. The issue is it runs entirely too fast, right? And so I had to slow that down. Typically, I thought about different ways to do that. I could use friction, but I didn't want to do that because I didn't think that would be very durable, right? Or very consistent. Could drop the voltage. That's not ideal because I want to preserve as much, of that actual, current and torque as I possibly could, right? So I ended up building just a gangster electronic speed controller. And these are also known as motor drivers. There's different names for them. And this is a gross oversimplification. And I'm sure that there are a lot of you in here that could explain this a lot better in more detail than I can. But basically, with a speed controller, you provide a supply current, right? And then you provide basically a pulse width modulated signal that is representative of the amount of time or the percentage of that supply current that you want to provide to the motor that you're driving, right? And it's kind of like an LED, right? LEDs, they don't dim. They're not dimmable. They're on or off. And so to cast the illusion of dimming, basically you just flicker them on and off very, very quickly, faster than the eye can really perceive that. But you do that, the brightness is basically just the amount of time that it's on in a given, amount of time versus off, right? So if you guys ever look at your alarm clock and you move your head real fast, you see segments of it, right? That's because it's not on constantly; it's always flashing, and that's somewhat similar to how these motor drivers work. So I didn't really have any of the components to build that. There was no 555 timer or really anything. They had the a PIC32 microcontroller, and I didn't want to get into having to reprogram that because I didn't think that would be terribly accessible and it requires special tools and all this stuff. So I went the gangster route. So basically, I took the 12-volt air pump and I gutted the bits of it that are actually the pump, and instead I fitted just a cylinder of plastic with the magnet on one side of that cylinder, and on the outside I paired that with the magnetic switch here, right? And so now when you supply 12 volts to this, then every single time that thing makes a revolution, right, it's going to close that magnetic switch. And then I could use that to control sending 12 volts to an electromagnetic relay, and then use that to power the main pump motor at a fraction of the time, right? Just like the pulse width modulated signal, only super mechanical and gangster, right? I needed a way to slow down this motor, which is a much easier proposition than slowing down the bigger motor that actually needs to do work, right? Because I don't care about dropping current on this as long as it spins at a lower RPM. I'm happy, right? There's no friction involved, and so to do that, I thought about using a voltage divider with relay or resistors. The easiest solution actually turned out to be I don't know if you guys were here for the lightning talk last night. Talked a bit about diodes And like classical diodes basically act as a one-way valve for electricity. And so electricity can pass through one direction but not the other. However, in those diodes, there's typically a 0.7 volt drop in voltage every time you step through one. Well, the controller had 9 of them, right? And so like all I had to do was keep tacking on these diodes until I had a voltage that would spin the motor at an acceptable RPM, right? So this is it functional here. You can kind of see like the reflection there is that magnet, catching the light. And so each time it passes through passes by that magnetic switch, it's going to send that 12 volts to the main motor and slow down my hand substantially, right? And I also learned that the proximity to the magnet itself made a huge difference in how long that switch was open and closed, right? And so I added this little set screw so I could make fine-tune adjustments on how fast everything worked, sort of on the fly, right? So tons of room for improvements. This is the Mark I Iron Man suit coming out of the cave, looking ridiculous, right? You just throw a microcontroller on this, right? And you could do a lot of crazy stuff. You could use this guy. Like I said, it communicates over I2C. You could use this to place exactly where you are in your grip, right? You could implement bidirectional motor controls very easily. Feed in some nice analog inputs. You could actually use the sensors that like genuine prosthetics use, right? Or make your own, whatever, right? There's a lot of room to go up from here. This is just meant to be a baseline, right? It's a proof of concept. So what's next for this project, for Jittery MacGyver? Ultimately the goal for this project is sort of to change the way that we look at the unremarkable and common stuff that we have around us all the time. And so I'm going to do a series of builds for just using the single Keurig, using kind of the same format. And I've thought about a few different things. I think water filtration and purification would be interesting. Lots of applications for cooking, also gardening and like maybe hydroponics, right? I think an aquarium would be fun. I'd like to see this fleshed out as a communications device, however primitive, right? And the last one, kind of more down my alley, would be firearms. And I was hoping to have this done for 44Con, but couldn't quite get it buttoned up. But I am currently building a handgun chambered in .22 long rifle, and firearms are like exponentially simpler than say like a hand like this. But it makes up for it by presenting completely new and interesting engineering problems, namely containing the 24,000 pounds of spec chamber pressure that is generated by a .22 long cartridge, right? It's a 1-inch long chamber that you need to build out of a Keurig that can withstand those forces. And I can't say this definitively, but I really think that the answer is going to exist in many, many layers. So, where do we go from here? A few takeaways. Like I said, man, the stuff that surrounds us all the time has huge amounts of potential. Huge, right? Start thinking about that. Next time you're in the hardware store, just stroll down the aisles and think about all the stuff you can build. Like start building stuff with your mind. Right? Maybe set up a scenario. There's going to be like a dozen clowns that pour in here with paintball guns. I have half an hour. What can I use? I take that piece and bolt that onto here and then make this. Like it's a really good way to actually, make that trip fun. Another takeaway is if you're stubborn enough, everything is sandpaper. For what it's worth. I genuinely believe that training your mind to work on these MacGyver problems, it makes you a better problem solver because it expands the domain of possible solutions just right off the bat, right? If you are comfortable and used to working under crazy limitations, right? When you actually have to step into a problem that maybe you don't have those constraints, that doesn't mean your mind is not going to come up with solutions that you would not have normally just arrived at, right? It just gives you more options to choose from. It means that it's very likely you're going to be able to come up with those solutions that are like, why didn't I think of that? I really think that working on this and working through these sorts of exercises, it helps you build up that muscle in your brain that gets you to those solutions. This is a chart of the amount of enjoyment you'll have in a typical project. I think this is especially true of ones that are completely like self-driven, right? Up here at the top is yeah, and down here is my God, why hast thou forsaken me? So just keep that in mind. Like after the fun and the challenging bits that you like wanted to work on, like strap in for Boring Valley, right? But it does get better because man, like after you fail and fail and fail and figure stuff out, like you start making breakthroughs and make breakthroughs, and then eventually, you know, this thing starts coming together and it starts getting exciting again. So just go into these projects mentally prepared for that, right? Next, take everything apart. Everything, right? Do you see what I did there? Yeah, so, and this is not the same thing as just destroying something, right? So the difference is when you take something apart, you learn from it. You do it with the intent of learning, and that is the only difference between just wanton destruction, right? And taking things apart is a skill. It's something that you develop and you work on, and eventually, in time, taking something apart will be like having a conversation with the engineer that created the thing. And people who do like reverse engineering and maybe like, you know, forensics work in here, you probably would testify to that, right? Makes sense? Same is very true with physical objects, but it doesn't have to necessarily be just about physical objects, right? So, if there's anything at all that you leave this room having remembered, please make it this. And it is kind of a challenge, right? It is of critical importance that you find a challenging problem that you care about, something that you're passionate about, and a challenging enough problem that like up until the very end, like you'll be like, I don't know if I could pull this off, right? I don't know if this is going to come together, right? If you go into a project knowing that like in a matter of time, like it'll work, it's not hard enough, right? Stretch yourself this way. It needs to be something challenging. And then after that, you find that thing, fight like all hell to solve it, right? And then the bonus part of that is come here and share it with people, because that'd be awesome. But I really feel like this is of critical importance, and a lot of the times, like in conversations with with people at conferences like this, like people are working on these little projects, and they have really interesting ramifications, right? Like some big, some small, whatever. But like usually it's just that one engineer or one person that's completely carrying the flag on this thing, and like the only people who have like complimented it at all would be like, you know, the engineer and his mom, right? But maybe I'll be the only person to tell you that thing that you're working on in your basement right now, or the thing that you've been kicking around, that idea that you've been starting to work out, like it is wildly important, like wildly important. And history is written very slowly, right? I'd like to think that maybe some of the stuff that I've worked on, like maybe my kids or something, they'll do a search or like try to excavate an old house or something to find an old notebook of mine, because like that one thing, that one idea maybe sparked someone else's creativity, which is like the first step and like the first flap of a butterfly's wings, right? You never know. Think about the number of people who were made famous posthumously, right? But even if your project or your work has zero historical significance whatsoever, it is still wildly important because it is fulfilling work for you. I feel like, for me at least, the times that I learn the most and the times that I'm like the most excited about doing work that I'm not necessarily jazzed about is when I'm doing stuff like this that I feel really feeds me, right? So if nothing, like find something challenging you care about, something you're passionate about doing, and then work hard to solve it. And definitely come back here and share it. That's all I've got for you.